Hi, my name is Thomas Kim. This is the third session about template metaprogramming. In this session, we will demystify constant versus constant expression. In Visual Studio 2017, I will create an empty solution. Here, I would say constant expr solution. I will name like this. I created a blank solution and I right click, add new project, Windows desktop wizard here, constant expr 01. Click OK. Unselect precompiled header. Click OK. Right click the project property, all configuration, all platform language. Here we will select Visual C++ 17 standard. Click OK. I will remove this part of code. Then here I create a function called CT. CT means compile time, initialization. Here I create std cout ct initialization. Then here constant int n, I would set 10. Initialize constant int at compile time. This is for we initialize constant int at compile time. Then int p is pointer, get address of n. Then we have to convert it int pointer. Then we modify the value of p, set 0. Now we display cout and std set w 3. We need to IO manipulation. Then here we display the value of n. Then address of n, we display address of n. std and there. Now we add one more line of code here. We take address of n, then star, then here address of n, then star, then the rest is the same. I will copy this line of code. Then here int, then I put just int, then the rest is the same. Now I copy one more line. This is p, then p, then p. We will rearrange it. Okay. std cout std and there. We will copy the same code and we rename it RT. RT means runtime initialization. CT means compile time initialization for constant int n. This is runtime initialization for constant int n. Okay, so we add one function here, get 10, return 10. I added one function here, then I change it to get 10. This is runtime initialization. So initialize constant int n at runtime. Now let's try it. I have to change it to RT. Here, CT initialization, RT initialization. Now Control F5. Please note that CT initialization and RT initialization, these two functions are actually the same, but for initialization of n. Okay, I will explain. CT initialization and RT initialization, the code are exactly the same, but this line of code, okay, this line we initialize int n at compile time. This is initialized at compile time with literal integer. This line initialize constant int at runtime by calling runtime function. Okay, I will change this name rt get 10. rt get 10. This is runtime. RT means runtime function, so I will change it to runtime function like this, and I will close it and run again. Control F5. So the result is very different. In this case, runtime initialization, when we used runtime initialization, n is 0 at this line of code. N is 0. Address, this line of code means we take address of n, then we dereference the value at address n. It is 0. It is the same. This line of code and this line of code is actually the same, and the value is the same, but in this case different. In this case the value is 10, in this case the value is 0, and the pointer is 0. P the value at this expression, pointer p, dereference p is 0, dereference p is 0. So this is correct result, this is incorrect result. And as you see, the address is the same. This is stack frame, so we need to check the addresses are all the same. Okay, so these values should be same because we reset value to 0, but this is wrong, incorrect, and this should be the same but different. Now here we initialized like that, like this. I will move this function, copy here, we will copy it here. Okay, and we create another function here, constant expr. We say compile time. Okay, compile time 10. If we can put it here, cp compile time get 10. Okay, If we modify like this, we delete 0, this CT. This is CT. Okay, now let's run it. So if we examine the result hasn't changed anything, we make exactly the same function. This is RT, this is CT. If we change it to CT, this function CT, the result is the same, exactly the same. Okay, I will explain what is the difference. This is runtime function. This is constant expr, means this function should be evaluated at compile time. Constant expr means the expression should be evaluated at compile time. Okay, so if we change it to RT, this is CT, right? We changed it like this and it still remains CT. If we build it, this is wrong, this is correct. This is correct result. Okay, so I will restore it back. This should be CT. Compile time. This is runtime. Okay, I hope you understand. Okay, now we will save it. I need to change the encoding. I will change it to Western code page. I saved it here. This program comes from here. We will compile it using GNU compiler, G++, STD, C++17, constant expr 01 cpp gexe. Okay, now we run this function g. Okay, now let's compare it with Microsoft, the result with Microsoft. This is from Microsoft, this is from GNU compiler, this is GNU compiler, this is Microsoft. The result is different. Say in case of CT initialization, this is 10 10 10 0. This is correct. Runtime initialization is correct. This part is correct, exactly the same, but compile time initialization is different. In this case, this is 10. In this case, it is 0. Okay, this is GNU compiler. We compiled using GNU compiler. This is we compiled using Microsoft compiler. This is for Microsoft compiler. So you have to be very careful about runtime initialization and compile time initialization. I will explain why this is wrong. Okay, I will explain why this is wrong. Why this kind of phenomena happens, why this kind of thing, I will explain this. I will make this part bigger. Initially, this CT gen 10 means this function, this function. If we provide constant expr, it instructs to compiler that expression should be evaluated at compile time. So it is compile time initialization. At compile time, this n is initialized to 10 at compile time. Then this is runtime. At runtime we modify the value of p. At this point here, this is not actually reading the value from the memory location. The compiler put the value of 10 here at compile time. Okay, so it is 10. At here, this is the last line, the next line, this line of code was this line. In this case, the compiler is smart enough that because we declare the n as constant, and is initialized at compile time, the compiler, Microsoft compiler, think that the value hasn't changed. The value of n hasn't changed, so it returns the same value like this. This value is actually resolved at compile time. Okay, but in this case, in this line, the compiler thinks the compiler reads the value at runtime. At runtime, this value is evaluated. And this value is evaluated, so it gives the correct result, and this is correct. In this case, in this runtime case, this is runtime initialization, so the compiler think this initialization should be done at runtime. So in here, the value is the value of n is read from the memory again at runtime, so it gives the correct result like this, all correct result. So the initialization, whether it is compile time or runtime, in this case runtime, is very important to understand the difference between compile time and runtime. I will give you another example. Now I will close I will create another solution. I will say constant expr2 02. I disable precompiled header. Right click, properties, here, Visual Studio 17, C++ 17 standard. I will add one more source code here. I add one more source code. I will just call it source code. Okay, then I will add a header file here. I would just say header file. Okay, here constant int n equals 10. I declared a constant integer here in header file. In source file we include header h. Okay, then I declare a function print const. Save. I will copy this IO stream in the header file. Then in the source file here, I declare constant int k. I will initialize to 20. It doesn't matter. Now I copy this text here. This is extern, like this. Okay, and I will define another constant expr int. I would say cxpr. I will initialize 30 here. Please remember cxpr is constant expression. This is constant int. Okay, all we defined in the header file. In the source code here, std cout print const. In print const function, std cout n equals n address of n std and there. Okay, I will copy this line. Then here say this is externally created k, 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 k. Okay, and we declare this one. Instead of cxpr, I would just say x. Okay, x, 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 x. Okay. Here std, cout, std, and there. Now I will copy the same code, this code, in here function main. Here in function main, and I will call this function print const like this, and we of course we have to provide this header file here, save, and we need to include the header file. Now Control F5. No, not this function. We have to make it start a project. Now double check. Okay. Control F5. Please note that in function main, the value of n is 10. In function print constants, the value of n is 10, the same. But please compare the address. Address is different. This is V30. This is VAC. This means, what it means is that the address is different means this n, this is constant n, okay, it defined in header file here. Constant n is defined only one place in header file, and when it is accessed in this source file, source CPP, and in constant CPP, this n and this n is different, because we can tell it because the address is different. Okay, in case of k, the value k, this is 38, 38, 38. In this case, k is defined in source file, CPP file here. Okay, and it is just a declaration. In this case, the address of k is the same. And about x, x is defined to constant expl here in header file. The value is 30. So in this, the address of x is 34 in this case, in the function main. In function print constant here is 90. The trailing 2 digit is 90. So this x and this x is different. Okay, if we want to make n, these two n point to the same address, to access the same memory address, then we have to move this constant in CPP file, for example here. Okay, then it should be extern, like this. Okay, then after modifying this, if we Control F, we build and run again, then the address of n is AC. The address of n is AC. Now it points to the same constant n. Okay. In the same manner, say we copy constant expl x here, here, for example, then can we turn it exturn? Can we do this? Now let's see. Okay, in the same manner, constant expr and constant. Okay, now Control F5. No, it doesn't work. It doesn't compile at all. It doesn't compile. Okay, it doesn't compile. Now I will restore back. It doesn't work. So this is one big difference. In case of constant expr, we cannot share with different translation unit. This is one of the biggest difference. Here, in summary, in case of constant entities of constant can be initialized either at compile time or at runtime. Okay, can be initialized either at compile time or runtime. In case of constant expr, it should always be initialized at compile time. Okay, another thing is entities of constant can be shared among different translation units. What I mean by translation units is usually the .cpp file. Okay, and in case of constant expr, entities of constant expr cannot be shared among different translation units. Okay, I hope you understand the difference between constant and constant expr. I will post the complete source code in the description section. I will put the link in the description section for this source code. Please download this source code and try it by yourself. Thank you for watching.